So yesterday we have solved these three problems, and we got stuck in clone graphs approach, and at last we have decided a approach where we have created a map against each node. Means for each node in original graph we have stored a corresponding copy node, and that after that we have iterated our original graph and its neighbor and corresponding copy nodes we have added. So that's how in two steps we have solved this clone graph problem. So today we will try to solve these three problems. Last one is walls and gates. So we will go with the rotten oranges first. So let's open this problem, because I think this walls and gates is not on LeetCode, but we will solve it. Okay, so we have this problem, rotten oranges. So my last submission was in 2022. So you are given a m into n grid where each cell can have one of three values: 0 representing an empty cell, 1 representing a fresh orange, or 2 representing a rotten orange. Every minute, any fresh orange is four directionally adjacent to rotten orange becomes rotten. Okay. Return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1. So the question is saying that we have three values in our array. First one is 0, meaning an empty cell, 1 representing a fresh orange, and 2 representing a rotten orange. So in this example, uh, let me zoom in. So we have this rotten orange. So after every minute, its adjacent oranges will also become rotten. So after 1 minute, this orange and this orange will become rotten. So this has become rotten, this has become rotten. And now after another minute, adjacent of these three, means these three rotten oranges are this orange and this orange will become rotten. And after this, only this is the adjacent orange, this becomes rotten. And after fourth minute, all oranges become rotten. So every minute, the neighbors of the rotten orange becomes rotten. So we just need to mm, return the time after which all oranges become rotten. So we can have also a case where no means all oranges cannot become rotten. Let's say if this orange was not present here, then in that case this orange will become isolated, so the orange cannot become rotten orange. So as we are iterating these neighbors, so this gives us a feel of using a BFS approach, that neighbor by neighbor, means level by level we can visit neighbors and mark the oranges as rotten. Mm, you can mark the oranges as rotten, and in each step we can store the time also. So what we can do is we can use BFS, so we can use a queue. So in queue we need to store the cells. Cells means cells having rotten oranges. So we need a queue of array, queue, new linked list. So first we will iterate this grid, and if our this grid has a rotten orange, so we can put that into our, means we can put our current cell into our queue. So after this loop ends, in our queue we will be having all the positions of rotten oranges. Okay, we can transfer the cell. Also, we need a visited array to check whether we have visited a particular cell or not. So let's call this as a visited array, and at the end we can check if any fresh oranges remains unvisited. So we can return -1, that this some means some fresh orange is not visitable. So we can, okay, so we have taken this, and we will take this, and we will create a new array. So this means we have a visited array. So now we will run our BFS. So until our queue is not empty, we will run our BFS. Okay, we also need time. We also need to store the time. Let's say we also store time. So initially we store 0 time. So what we can do, we can extract a current cell from our queue, and we will mark visited of current I, means this and this, as visited. So we have marked visited our this current cell, and let's say we also have a answer variable time. So let's say time is 0. At the end we will return this time. So our time will be max dot maximum of this time, current of 0, and this time itself. Now we will move to all the adjacent cells, these cells. So in order to move to the adjacent cells, let's create a direction vector which will help us to transverse in all the 4 directions. So -1 0 0 -1 1 0 and 0 1. So this will help us to transverse in all the 4 directions. So dir from these directions. So new x will be current of 0. Get a set. We need to not visited current of 0 and current of 1. Current of 0 plus direction of 0, and y will be current of 1 and direction of 1. And we will check if our x is greater than 0, means we are validating our new directions, means new cells which we are going to visit. X and y should be greater than 0, x should be smaller than n, and y should be smaller than m, and our cell should not be visited. And also the cell should not be empty, should contain a fresh orange. So 1 is indicating a fresh orange. So after all these validations, so from this current rotten orange, we will move to the fresh orange after validating all these points. That new cell, this the indices of the new cell should be within the constraint, and the cell should not be already visited. So we need x and y. So new cell should not be visited, and new cell's value should be equal to 1. If all these constraints pass, then we will add that cell to the queue. Mm, so we will add x, y, and we will increment our time. So we will increment this current time, which will be at second position, plus 1. So this way we can return time at the end. So we are not covering a case where we will be not able to visit all the oranges, means we will be not able to visit some of the fresh oranges. In this example we are able to visit all the oranges, means this is a rotten orange, so this will first make these oranges rotten, this 1 and 2. Then these 3 rotten oranges will make this and this orange rotten. Then these 5 oranges. So adjacent to this orange is this fresh orange, so this will become rotten, and at the end this will all become rotten. So suppose if we don't have a fresh orange here, then in that case this orange will be isolated, so it will be not visited. So at the end what we can do, we can iterate our visited array. Sorry, I plus j, and we can check if our grids value at ij position is 1, that means it has a fresh orange and it is not visited. Then we can say we have not visited all the oranges, all the fresh oranges have not become rotten, so we can return -1. Otherwise we will have our time. So do we have any issue here? So initially in this step, adding rotten oranges to queue. Then in this step, marking neighbors of rotten oranges as rotten. Checking if all oranges have become. Checking if no fresh orange is left. Orange is left. So these are the three steps, I think. Let's see if this works. Okay, we have this boolean array. We need to make this as a boolean array. Int cannot be converted to okay. So this is a array. Let's see if this works. Okay, so we are getting two output for our this case. So we need to debug it, I think. So what we are doing, we are adding to our queue. We will initially for this example add 0 0 and 1 0 for the time variable. So our queue initially will contain was this cell. So 0 0 1, okay, and our queue is not empty, so we will remove this from our queue, and then we will mark it as visited. Okay, then we will take time as the maximum of, okay, we need to take it as a maximum of 2th value. So we are storing time at the this index. Okay, now it's working. So what I was saying is, if we remove this orange, so let's try removing this orange. So removing this orange means uh, we have to remove this one, this one to 0. We will then this. Uh, wait a second. Then this particular orange becomes isolated, so it will never get rotten. So that's why our code should return -1 in this case. So it is returning -1 as this cell cannot be visited ever. So let's submit it. Okay. So in this case, We are returning 0, and we need to return -1. Okay, 0 -1. So this case doesn't have any. Okay, false. We need m here instead of n. We need to iterate the visited array. Okay, now it's working. Let's submit it. Okay. Hmm. Let's debug this. So we have this array. So our expected answer is should be 1, and we are giving output as 2. So initially what we will do, we will add this index, and this index in our queue. Okay. So after removing this index, we will not find any valid adjacent. So we will add nothing to the queue. So now then we will have this 2. So in the queue, we have first we will process this. So we will process this, and we will see this one and add this to our, remove this and add this to our priority queue, and mark it as visited. Are we marking it as visited? No, we are not marking it as visited. Okay, so instead of queue, I think we need a priority queue. Means priority queue based on the time. Okay, let's priority queue. New priority queue. And we need to sort values based on this second index. So we will take this as, means we will pop the element having the less time first. Okay. Okay, still getting issue in this case. Initially, our priority queue will contain 0, 0, 0 and 0, 1, 0 and 0, 1, 2, 3, 3, 0, 0. So we will suppose we pop this first. If we pop this as first element, and we mark it as true. So let's say we add dash and mark it as true and take time as the maximum of this variable in this variable. Okay. Then we will move to the next index is having value 1 and not visited. So we will move to this and we will add this to our priority queue. We will remove this and suppose we add this variable. So this variable has maximum time, so it will be added at the last of the priority queue. Means we will add 1, 1, 0, 1 in the priority queue. Then we will pick this element, and what we will do, we will mark it as visited and add this particular element to the queue, which will be 1, 1 and time will be 1 itself. And we will remove this variable. Then we will mark this as the true and add nothing to our priority queue. Okay. Now we pick out this element and mark it as true. So I think after adding, we need to mark the variables as true. Then we will mark visited of x and y as true. So we need to initialize this variable here. Okay, now our these cases are running. Let's submit this. Okay, we have found a submission. So let's look at our previous submissions. Okay, so I am just using, don't know what I am using, but it's a pretty complex logic. So let's see if this has a better approach than we have implemented. Okay, so checking if no fresh orange is left. Hmm, BFS solution. Okay, it's the same approach which we are using. We are adding fresh oranges and we are counting the number of fresh oranges we have made rotten. So instead of reiterating this visited array, we can here itself calculate the number of oranges which have value 1, so which we have visited. If that becomes equal to the number of ones we have initially visited, so we can avoid this check. So I think other than that, we have implemented the most efficient approach. So now we will solve Pacific Atlantic water flow. So there is an M into N rectangular island that borders both Pacific Ocean and Atlantic Ocean. The Pacific Ocean, the Pacific Ocean touches the left side and top edges. So we have on the left side and top Pacific Ocean, and on the right side and bottom side we have Atlantic Ocean. Okay, so the island is partitioned into a grid of a square cell. Okay, so this is an island. Basically, this grid is an island between these two oceans. You are given an M into an integer matrix heights. Okay, where height RC represents the height above the sea level. Okay, height above the sea level. So basically, the value here means this two value means two height above sea level, and this five value means five height above sea level. So cells. Okay. The island receives a lot of rain, and the rainwater can flow to the neighboring cells directly into four directions. These four directions. Okay. If the neighboring cell's height is less than or equal to the current cell's height, so water can flow from adjacent cell to an ocean into an ocean. Okay, so the question is saying, suppose it rains on the island, and suppose it rains on this cell, this fourth cell. So water from this fourth cell can move to the uh, its adjacent cell if the value of that adjacent cell is less than or equal to this 4. So from this 4 the water can flow to this 3. Wait a second. And from this 3 the water can flow to this 1. So what we need to return, we need to return a to the list of grid coordinate result where result I denotes that the rainwater can flow from this cell to both. Return a to the list of coordinate results where result I denotes that rainwater can flow from cell to both the oceans. Okay, so we have this output here. The following cells can flow the flow to the Pacific and Atlantic cells as shown below. So this cell means we need to return cells. So in this answer we have a all answer cell 04, so which is 04, so this cell 0 1 2 3 4, so 5 is the answer. So how 5 is the answer? So from 5 itself the water can move directly to this ocean and this ocean. We can assume these oceans having value -1. So from 5 it can move to a -1 value, which is Pacific Ocean, and also to the Atlantic Ocean. So I think these cells which are highlighted are the answer cells. So from this 4 cell also, the water can first move to this Atlantic Ocean and to Pacific Ocean. How it can move from this 4 to move to this 4, because this has a value equal to this, and from this 4 it can move to this 3, and from this 3 to Pacific Ocean. Similarly for this 4, the water can move to this 3 and then to Pacific Ocean. And now for this 5, the water can flow from this 5 to 3, 3 to 1, and 1 to Atlantic Ocean. And to Pacific Ocean, it can move into left direction from this 5 to 4, and from this 4 to 2, and 2 to Pacific Ocean. Okay. So we can take a cell other than from these and see that water is not flowing to both oceans. So let's take this 2. So from this 2, the water can move to this 2, and from this 2 it can move to Pacific Ocean. So it has moved to Pacific Ocean. Then now we need to move to Atlantic Ocean. So from this 2, we cannot move in this direction, as these have value greater than 2. So there is no way that we can move to Atlantic Ocean. So we have to, from a cell, uh, let's say we are at a cell ij, we need to move to cell having value smaller than or equal to current cell value, and we need to return all the cells. Okay, Mhm. And then having constraint 200. 4 to 3, 3 to 1. Okay. So condition to touch Pacific Ocean. So condition to touch Pacific Ocean is that if our variable, our cell lies in this particular column, so J should be 0, or if it lies in this particular row, or I should be 0. So this is the condition to touch the Pacific Ocean. So condition to touch the Atlantic Ocean will be if our uh, cell lies in this value. So this means suppose we have a height dot length. So this is our rows, and height is GHT height 0 dot length. This is our column. So that means this column should be, means column should be last column. So last column means m minus 1, or it should lies in this row. So this means I should be the last row. So these are the conditions which we need to check. So suppose what we can do, we can start from a cell, and we can, for a particular cell, we can apply DFS, and we can check whether we can go in all direction, and we can see whether if it hits Pacific Ocean and this other ocean. If it hits both oceans, then we can add it to the uh, our answer list. So if this condition satisfied, then this means Pacific Ocean, it hits Pacific Ocean, and this satisfied, then that means it hits Atlantic Ocean. And when both conditions satisfy, we can add it into our current answer list. Or can we do the reverse of it, like from this cell? We are sure that these cells uh, touch to Atlantic Ocean. So what we can do from these cells, we can we can go into reverse direction, means in increasing order, and we can mark the cells like that this particular cell can go to the Atlantic Ocean. Then we can start from these edges, and we can mark the cells like this particular cell can go to the Pacific Ocean. Let's iterate over every cell. J is equals to 0, j smaller than m, j plus plus. So we are at our current cell. So for current cell, let's say we call DFS. DFS to check if it hits the Pacific Ocean, or can check both. In this cell, I'm working with Python throughout my career. HR doesn't understand it's just a programming language. Java then fake experience at current company uses Java to get more interview. Python throughout my career. Let's call this uh, DFS and IJ. We are at INJ cell. We can pass a visited array having size equal to this. So public, let's say we initialize it is a boolean and check if we can visit Atlantic Ocean from this position. So this will be of boolean type. So int I int j boolean visited array. So if our current position, so in the case of Atlantic Ocean, these conditions will met. So if this condition met, so we can return true. So as we know, our direction vector means we need to now move into all the adjacent positions, four directions. So this is our this vector we will use to iterate in all the four directions. So 0 minus 1, 1 0, and 0 1. So we can iterate this. So our new x will be I plus directions of 0 and y will be I plus j plus direction of 1. So we can validate our new adjacent cells x and y. This x should be greater than equal to 0 and this y also should be greater than equal to 0 and this x should be smaller than n, so we don't have n here. Okay, we haven't also passed the heights here, so we need to pass height also. HEIGHTS. We need to define these heights here, so we can define our n and m globally. So okay, so we can use now our n and m here, and our this should not be visited. So visited of xy should be false, and the height which we are now going to move should be smaller than our current height. So heights of xy should be smaller than or equal to heights of I and j. Then only we can move to the adjacent cell. Okay. And we can also mark our ij position as visited. Okay, now we can call our dfs and see if our this dfs call for this variable x y heights and visited returns true. In that case we will return true, otherwise at the end we will return false. So this is how we can visit our Atlantic Ocean. So I'm trying to implement a brute force solution. So this is for visiting Atlantic Ocean. Similarly, we need to change this condition in this DFS to this condition. So we can check if that is visiting to Pacific Ocean. Suppose we have a variable here, extra variable to decide if it's Pacific Ocean or Atlantic Ocean. So suppose we have a character. So in the case of Atlantic, we pass A. So let's say character ocean. So if our ocean is A and these conditions met, in that case we have uh, reached the boundaries. Or if our ocean is Pacific, that means for Pacific Ocean, let's define P, and our these conditions met. If one of I or j, then we can say we have okay. So this is for Pacific Ocean. In the case of Pacific Ocean, we will pass P, and we can define the this list, our answer list. And if our both Pacific and Atlantic are true, in that case to our answer list we can add mm, the current cells I and j. I think this will not work in Java. We need to define a list, then we can add. Let's see. And at the end, we can return our answer. But this approach will, I think this will be a exponential approach. Let's see. Okay. Okay, so we need to add a new array list. New array list, and we will add cell.i, cell.j. Then we can add it to current cell tour also. Okay. Mm, okay. Okay. It's working for these two examples. Mm, but it will give TLE because we are iterating every path. So I think it should give TLE. Let's try to submit this. It's accepted. Okay. Let's ask GPT time complexity. We need to account for the following outer loops. This is n square, and in n square we are calling a function dfs n square into. So how much time dfs will take? 4 directions. This is n into n k. So why our total time complexity is n into m? Okay, that's the approach we have discussed, that we can start DFS from boundaries. Redundant DFS server. Okay. For Pacific Ocean, start from top row and left column. For Atlantic Ocean, start from this. This reduces DFS calls to n plus m for each ocean. Okay, so we can call DFS from boundaries also. Okay. Mm, in our previous submissions. Okay. So we can start from boundaries. Let's see any solution which we can understand. The two Q and a door was equal to one Q. DFS version. Okay. So here also we are starting from boundaries. Okay, so this is the approach we can use. This approach we can use instead of starting from every value, like we are starting our DFS from each I and j index. Uh, we can start from it these boundaries and mark the cells that particular cell can visit Pacific Ocean, and from this we can mark that particular cell can be visited from Atlantic Ocean, and at the end we can get cells which can be visited from both the oceans. Okay, so we have also done this question. So I think that is it for today. Tomorrow we will solve this question, walls and gates. Okay, so it is on LeetCode Premium, but it will be present on this site also. So tomorrow we will solve this problem, and also we will solve this surrounded region. Okay, so I think that is it for today.